Alright, so this video is going to be on graphing or not exponential, but logarithmic functions. So a logarithmic function has a few key things. We're going to graph a very simple one. So let's just do y equals log base 2 of x. So a couple key components to a logarithmic function. There is a vertical asymptote, and it is at x equals 0 in this problem, because for a logarithm, you can't plug 0 in for x. So it is impossible to do the log base 2 of 0, because 2 to some power cannot equal 0, right? If we set up and write it as an exponential, this actually doesn't work. It doesn't have an answer. So the reason the vertical asymptote is at 0 is because you can't do the logarithm of 0. And so we'll draw in a vertical asymptote at x equals 0. So there is your first part. The next thing that you want to do for a logarithmic function is you want to find points. After you've got the asymptote, you're pretty much good to go. You just want to find points, and what I do is I create a table, and you're just going to pick x values. Now, the very important thing that you want to do is you want to pick x values that are x values should be powers of the base. Powers of the base are like take the base, so the base in this case is 2, and raise it to an exponent. So 2. So for example, that would be 4. So 4 is a power of the base, so I want that to be one of my x values. 2 is also a power of the base. 1 is a power of the base. I could even do a fraction like 1/2. All of those are powers of 2. Something that is not a power of 2 would be like 6. 6 isn't a power of 2, it's a multiple of 2. So to find the y values, we're going to take our x values and we're going to plug them in for x right up here. And so log base 2 of 4 is 2. You plug in 2, and log base 2 of 2 is 1. Plug in 1, and the logarithm of 1 is always 0. And then plug in 1/2, since the base flips, that's negative 1. And so we're going to graph those points on our coordinate plane, and we're pretty much done. So 4, 2, okay, and then 2, 1, 1, 0, and then 1/2, negative 1, and hopefully I can make a nice looking graph for everybody. There would be a point at 8, 3 if you were curious. And that is what a logarithmic growth function looks like. A couple things that your teacher may ask for. They may ask for the domain of the function. So if you look at how far to the left the graph goes, it doesn't equal 0, so I use a parentheses and then 0, and then it goes to the right, so to positive infinity. And then the range is always going to be negative infinity to infinity, because the range is all real numbers. It goes all the way down and it goes all the way up. Alright, so that's the basics of graphing a logarithmic function. Okay, got to find a vertical asymptote, that's the first thing, and then you have to find points that you're going to put on your graph. Okay, so let's try to make it a little bit more exciting. Alright, so there's a function, the graphing form, or a general form, let's call it that, would look like this. Y equals a times log base b of x minus h plus k. Alright, so if you see something that has a variety of numbers plugged into it, that it looks of this form, you're going to have to do a few different things to graph. We know that h moves the graph left and right. Right? K moves the graph up and down. And A makes the graph reflect if negative. Right? So if A is less than 0. And the base is still the base. Now one thing that we want to highlight is we want to highlight this x minus h part. Since the vertical asymptote was at x equals 0, when you see something in the last problem, when you see something in parentheses like that of the parabola, or the logarithm, take x minus h and set it equal to 0. This is how you'll find the vertical asymptote. So we would add h, and then x would equal h. That would be my vertical asymptote. So let's try just finding the vertical asymptote of one problem. So let's take this and say it was y equals 2 log base 3 of 2x minus 1 plus 5. So if I wanted to know what the vertical asymptote is, right? The vertical asymptote, what is that? What we're going to do is we're going to take 2x minus 1 and we'll set it equal to 0. Because you can't have 0 inside of a logarithm or negative. So we add 1, so it'd be 2x equals 1, and then we divide by 2, so x equals 1 over 2. This would be my vertical asymptote. And if I were graphing it in this coordinate plane over here, I would put it right here, right in between 0 and 1. And then I would go about finding points for my graph. So let's try to put it all together, and then we will be done here. So y equals log base 3 of x plus 1 minus 2. Okay, so log base 3 of x plus 1 minus 2. First thing I want you to think about is I want you to think about finding the vertical asymptote. So let's take x plus 1, let's set it equal to 0. Subtract 1 from both sides and x would equal negative 1. So we're going to have a vertical asymptote at negative 1 on this coordinate plane. Hopefully that's making sense. Right? This also describes a shift to the left 1. So our vertical asymptote has moved over to the left 1. Alright, now points. Here's where things are going to get a little interesting, because we said you want to plug in powers of the base. So our base is 3. So what are some powers of 3? Well, 1 is a power of 3. 3 is a power of 3. 9 is a power of 3. We could say, let's use all of those, okay? 1, 3, and 9. Well, here's the thing, is you cannot plug in these numbers as x and get something that you could do in your head. You could plug them in and have to use a calculator, but we're doing this without one. So if you were to plug in 1 for x, what that would get you on the inside of the logarithm is 2. And we don't know the log base 3 of 2. So what you want to do is you want to plug in numbers, plug in x values that create these 3 numbers. So think about this. You've got x plus 1 on the inside. What could I plug in for x that would create 1? That'd be 0, because 0 plus 1 is 1. What could I plug in that would create 3? That would be 2, because 2 plus 1 is 3. And what could I plug in that would create 9? That would be 8, because 8 plus 1 is 9. Now to find the y values, you're probably going to want to use some scratch paper off to the side. So we are going to have to just manually plug these things in. So y equals log base 3. And I plug in 0 plus 1, then minus 2. So this is log base 3 of 1 minus 2. And then what's the log base 3 of 1? That's a 0, then minus 2, so it's negative 2. Alright, so my point is at negative 2. When you plug in 2, you get 3 on the inside, so the log base 3 of 3 is 1, and 1 minus 2 is negative 1. When you plug in 8, you get 9 on the inside, so the log base 3 of 9, that exponent would be 2, and so 2 minus 2 is 0. You've got 3 points, and go ahead and graph those. So 0, negative 2, 2, negative 1, and 8, 0. And you're just going to make a nice curve down and curve up. And if you have to give the domain and range, the domain is now the x values are greater than negative 1, so it'll be negative 1 to infinity. And the range will still be all real numbers like that. Alright, well, that's how you graph a logarithm, and hope you have a great day.